need to go outside.
You're fine. You should recognize this word. Okay? Now, let's take a trip back to memory lane. On there.
I don't like my
Solving systems of equations. You learned back in pre-algebra and algebra, the first thing to solve two equations and two unknowns, you graph them. Right? So wherever the two lines crossed, that coordinate was the solution to the system. Right? Okay. And then you did substitution, where you solved one equation and substituted that information into the other equation. That was substitution. And then you also did elimination. And in PreCalculus 10-1, we did substitution and elimination. We also did it in Algebra 2 with 3 equations and 3 unknowns. And then in Section 2 and Section 3 of this chapter, we learned how to find an inverse. And once you found the inverse, you set up your matrices into a matrix equation, and you multiplied both sides by the inverse. And that gave you your solutions. So there were 4 different ways of how you solve systems of equations. Now I'm going to give you the 5th way today with determinants. And really, this probably might be the best way out of all 6. Okay, so in Algebra 2 you were taught how to find a determinant. You actually probably were shown how to use it. If you don't remember, I only had a few people in each class that said they remembered it. You should have been taught it, I'm sure you were, but you can't remember everything. So that's okay. So by show of hands, who remembers just the word determinant? Okay. And who remembers how to find it? Kinda? Okay. And who knows what to do with it once you find it? Alright, so now we're getting somewhere. Alright, so let's take a look at, let me get my book. This, you'll put this on your, you're going to put this on your reference sheet, how to find a determinant of a 2x2, and then we'll talk about how to find a 3x3 determinant as well. Okay? And who remembers the phrase Kramer's rule? Alright. Okay. So, determinant, if you're putting this on your reference sheet of a 2x2. So here is A, B, C, and D. And we want the determinant of A. This is just notation how to do this. So this is actually the physical notation of your matrix. Looks like absolute value signs, but this means we're wanting the determinant. I'm just showing it so you, in case you see this stuff, you can say, wait a minute, I recognize this. This is a determinant. So this would be A times D minus B times C. So it's the denominator of how you find your inverse of a 2x2. Right? You recognize that? So that would give you a value, a number. That's what you want. Okay, so now we're going to have a little space here because we're going to show how to do the 3x3 down here. I'll do an example of a 2x2 over here. Let's do, let's see, we'll do number 34. 6x plus 12y equals 33. And 4x plus 7y equals 20. Now, you could put this in slope-intercept form. Stop talking. Put it in slope-intercept form.
I'm working this out in my head.
Oh, really? Yeah, that's good. Well, what's the answer then?
I'm still working it out.
Okay. You can put it in slope-intercept form, you could graph it, you could do substitution, elimination, you could find the inverse of it. You all know how to do all those things. I want you to come up with the determinant of this. 6, 12, 4, and 7. Everybody do that. Follow the formula there. The diagonals. Oh, somebody put this on here. I'll have to eat it. And what I want to point out is how to do this, because this is what you're going to need for your 3x3s, or your 4x4, or your 5x5s, and 6x6s. Notice that all your matrices have to be square. If they are not square, it does not work. Okay? Square meaning the same amount of rows as there are columns. The downward diagonal, A times D, the downward diagonal is the first one, minus the upward diagonal, 48. So my determinant for this is -6. Okay?
Okay.
What?
Nothing. I said now what?
Now, how do we solve, how do we get x and y? We know how to find the determinant. What good is it? So to find the determinant of a 2x2, we'll write this over here. To find the determinant, what you're going to do is you're going to find the determinant. D stands for determinant. To find the value of x, you find the determinant of your x values over the main determinant. In this case, it's going to be -6 over here. So let's understand what we have here. This is our basic equation. ax plus by equals r, and cx plus dy equals s. The main determinant we found, we're going to write it like this. This is a division. A, B, C, D. We're going to find the determinant of the main matrix, which is AD minus BC. But the top, the D sub x, is special. You find the determinant the same way, but we're going to replace the x column, the x coefficients, with the answers. So that would be R and S go in this position, and B and D go in this position. They didn't change. The y column didn't change. And this is how you solve for any of the variables. If I wanted the y variable, I would put the R and S in the y position, and A and C would still be here. So it's the exact same thing if you have a 3x3, a 4x4, or 5x5. If you wanted the z value, you would put the answers in the z column. And then you have to find those determinants. If you find those determinants, you divide the two. That gives you the value of the x. So if we look at this, we've already done the first part of this. 42 minus 48, that's -6. That's my denominator. That's the main determinant. That's this position right here. So if I want to solve for x, I need to find the determinant of 33 and 20, replace the 6 and the 4. And everybody get that for me, please. Use your calculator if you have to. Everybody check my math, make sure it's right. Make sure you can do this. Don't just copy down what I'm doing. That doesn't help you.
No, I was confused for a second why you got 33 and 20, but then I remembered.
Okay. So x is the determinant with the x column removed divided by the main determinant. So what do we have? -9 over -6, which is positive 3/2. You just found the x value of that system. Now, find the y value for me, please. Let's see if you can do it.
So do you want us to do it this way, or you want us to just plug that back in? The equation.
No, I want you to do it this way.
Okay.
Because really, you should be able to do most of these in your head. What would really freak out your algebra students is if you went to them and you knew they were solving systems. Of course, they have easier systems than you do. You could sit there and probably do the crisscross, find the determinants and do it in your head, and that would really freak them out. You say, well, you're just an algebra student. I mean, Mr. Locke. We don't use calculators.
We can call them morons.
Yeah. You guys are just morons.
So ding dongs.
Once you get to Mr. Locke's PreCalculus class, you're teachable morons.
Tell my mom.
Are you?
No.
Well, have her call me so we can discuss your grade.
What is my grade here?
I don't know.
I don't either.
Okay, so d sub y, 6 and 4, and 33 and 20. So that's 120 minus 132, negative 12. So y is going to be d sub y over d, or negative 12 over, what's d? Negative 6. So 2. So 3 halves, 2 would be where those two lines cross.
I'm just having trouble. Where?
What?
I'm having trouble finding. Oh, okay. Never mind. You just have I got you.
That's all it is.
Are you done our whole assignment today?
No, that's a 2 by 2. Yes and no. I mean, that's how you do
What's
it.
what's
But
D?
you gotta do a 3 by 3.
What's D in the equation? Like
Where?
what number is D?
Right here. A, B, C, D.
Okay.
Okay. All right. That's how you do this. This is really Kramer's rule. Doing these multiplications at diagonals, and that's what we're going to show Kramer's rule with 3 by 3s. And how you solve for x, y, and z is putting the determinant of each of those columns that you're replacing over the main determinant. Okay, so let's do a 3 by 3 and kind of show a little bit different stuff here. Nothing's really changed, you just have more calculation to do. So hopefully you got that in your reference sheet, because you'll probably forget exactly how to do it in another month. Okay, let's do number 40. This is a 3 by 3. 5x minus 3y plus z equals 6.
Mr. Young Thug.
Yeah.
Where did you get, like, how did you do that differently with the y than you did with the x?
I changed the y column with the answers,
Because x.
33 and 20.
Okay. Okay, alright.
Got it?
Yeah,
Okay. So whatever variable you want to solve for, that's what you replace.
okay.
So here we're going to have x, y, and z. Again, on the test, we're starting from section 5 on, because we already did stuff in section 1 through 4. So I'm going to say solve this system with inverses, solve the system with determinants, and you guys show me how to do that. Okay. So we'll have 2 by 2s, we'll have 3 by 3s. So the first thing you want to do is find the main determinant. So let's first write this down. 5, negative 3, 1, 0, 4, negative 6, 7, 10, and 0. So this is the main matrix. You should recognize what I'm going to do here in a second. The first thing you do is put the first column here and the second column there. Add these two columns to your matrix. Does this look familiar?
Yep.
Alright, the next thing you do is your downward diagonals. Starting here. So 5 times 4 times 0 is 0. And you're going to add all your forward or downward diagonals together. Negative 3 times negative 6 is positive 18. And 18 times 7, 70, 56 is 126. And 1 times 0 times 10 is 0. Those are all your downward diagonals. Now, I'm going to stop. I want to make sure you're getting this. How to do this process. Now, I know you've done this all review, but I want to make sure you're remembering it. Can I go on? Anybody need me to stop? Alright, so those are your downward diagonals. Now you need to subtract, which is exactly what you did with the 2 by 2. Remember you went A times D, that was the downward diagonal, minus the B times C, which was the upward diagonal. So it's the exact same type of thing, except you have lots of them. The upward diagonal, 7 times 4 times 1, that's 28. 10 times negative 6 times 5, negative 300. And 0 times 0 times negative 3. Everybody calculate that, please. Raise your hand if you got that.
Oh, wow.
Take a look. See what you did wrong?
Yeah.
Okay. Alright, now what did we find? The main determinant. This is your denominator when we're finding d sub x, d sub y, d sub z. Alright, so this is going to be your denominator. You still solve it the same way as a 2 by 2. So what you're going to do now is you're going to find d sub x, d sub y, and d sub z. So I'll get you started, and then you guys do the work. So, Bailey, how am I going to set this up? I'm finding x. Well, I'm finding d sub x, the determinant. What am I replacing?
The y.
The what?
The y. Wait, the x.
The x column.
Yeah.
Okay, the 5, 0, and 7 I'm going to replace with the answers.
Yeah, okay. Alright.
Alright, so 6, 22, 13.
Negative.
And then everything else stays the same.
Negative 13.
Thank you.
1, negative 6, 0.
Okay, now, what do I do?
Add the first two.
Add the first 2 rows, and you all do the calculation, because I'm just not very smart. You need to find d sub y as well, so when you're done with that one, do the d sub y, and then also d sub z. And then put it all together for me. I'll work it out as well. Don't look until you're done so you can match up your answers, see if you did something wrong.
off.
Yep.
I messed up, dude.
All right, so let's take a look.
22.
Hmm?
See the negative 722.
How did I get it?
Oh, wait, I was in the wrong one. Okay.
I know those are correct, so if you got something wrong, take a look at it
Yeah, what?
so you can find where are you at, which one, D of X? D sub X.
I totally messed up these numbers.
Oh, you did this. Where's this from? You gotta do the downward ones first.
Well, that's probably
And this isn't right either. So is this your downward one? 0, 18 times 13. That's not right. You need a calculator.
Oh.
You got it set up right. So do your down ones first. And just check this one. All right, let's see. Let me see.
Oh, I didn't get CC.
That's fine. Let's go ahead and take a look at d sub x. Make sure we can do that. Okay, so d sub x we found to be 398, and you put that over the main determinant, which was 398. X equals 1. Okay, and I'll show you what we did up here. D sub y. We got d sub y negative 796. Okay, so negative 796 over 398. That's negative 2. Who finished z, d sub z? Did you get negative 1990? Yeah. So that's negative 1990 over 398. That's negative 5. So my answer is 1, negative 2, negative 5. Now I want you to think about something here. This only took 4 steps. Now granted, each step had a lot of calculations in it. But my opinion is this is still better than the inverse. But the other part is this. We're using smaller matrices to show you how to do it, so you can do it with very large matrices. This is really a great way to solve the system. Now you may think, if I just did substitution elimination, I could probably do it faster. Or what you did in section 2, we just got the lower triangulars to be zeros, and then you set z equal to whatever, and you could solve it. Some of you are very good at that. That's a great way to do that. That's kind of in between what we said over there for the steps, or how many different ways you've learned to solve those. That's another way, the triangular zeros. But that was really elimination, is what that was. Okay? So, how are we with Cramer's rule? That was a shortcut. We were going to take 3 days to do this because I was going to teach about cofactors and minors. But all that, and I've never been shown that. What I've been shown is the Cramer's rule, the diagonals and stuff. And so it took me a couple days to look at cofactors and minors to realize that stuff was just this shortcut. Cramer saw that cofactor, if you read your book, which I know you probably won't, but we're not doing the beginning steps. The beginning steps was understanding where all this came from. That's not important. What we want to know is how do you solve systems of equations. So this is just another tool. I don't need you to know what a cofactor and what a minor is, because it's actually what these diagonals are doing. But they just took you with baby steps. And I was going to take a few days to actually show you all that. It's just not that important. What's important is, can you do Cramer's rule to solve the system? Okay. So your homework's on page 691. You're going to do 33 to 47 odds. All right, so you have all those answers. Make sure you can do them. All right.